Here's what we have. First of all, the notation. The inverse of a function f of x is written with f, what looks like a -1 exponent of x. This does not mean the reciprocal. It means a new function, the inverse of the function f. Here's some information about an inverse. The inverse of f undoes f. That is, if f operates on 10 and gives 85, then the inverse will operate on 85 and give us 10. The idea is that if x is 10 in the function, y is 85. If x is 85 in the function, y is 10. They have their x's and y's in reverse order from each other. That's the information that we'll use to find a rule for an inverse of a function. Let me show you how with an example. The given function here is 1-to-1. We're told that. We want to find its inverse analytically, which means by hand. Here's our function, x cubed plus 1. The first thing that I'm going to do is revert or put in a y for f of x, so that you can see that I'm going to reverse the x and y. Interchanging every single ordered pair in the function, making every x a y and every y an x, I get this statement. And what I need to do is solve for y, and I'll have the inverse. Subtract 1. And to undo the cube, remember what we can do is take the cube root of both sides. And the cube root of y cubed is y. The statement, the cube root of x minus 1 equals y, is what I was looking for. This function, written with the correct notation, f inverse of x equals the cube root of x minus 1, is the inverse of f of x. What I want to do now is graph this inverse and its function in the same coordinate system on a calculator to show you how their graphs are related. So let's go on to our graphing calculator. And in y equals, I'll first put the function x to the third power plus 1. And then I'm going to put in a cube root. You can find the cube root under your math key. It's option 4. And inside my cube root, I have x minus 1. Don't forget to close the parentheses. We can see these graphs on a standard window, but I'm going to set the window to -5, 5, -5, 5. I think it'll show better what I'd like you to see. There's x cubed plus 1, and here comes the graph of the inverse, the cube root of x minus 1. What you need to note, and I'm going to put in a third function for you, y equal x, and have it graph, is that the function, which is the top curve, and its inverse are reflections of each other about the line y equal x. In addition to that, if they ever intersect, they will intersect on the line y equal x. If you ever graph inverses and functions and think the graph is distorted, remember that your calculator has a zoom square option that will square the screen for you, and it might make your function and inverse look better. I want to use that particular piece of information to do this example. We're given a function with a restriction attached. We want to find a rule for the inverse of the function and then graph the function and its inverse on a graphing calculator to support our result. Recall that x squared has as a graph a parabola. A parabola would not pass the horizontal line test. But this is not an entire parabola. The restriction keeps only the part of the parabola that's greater than or equal to 0. So I do have a 1-to-1 function because of the restriction, and now I'm going to find a rule for the inverse. As we did in the previous case, I'll begin by putting in a y to get -x squared plus 4 equals y, and I'm going to switch every single ordered pair by switching x and y. Now I need to solve for y. I'll subtract 4, multiply through each side by a negative 1 to get negative x plus 4 is y squared. This is easier to see if you write 4 minus x. And now I need to take the square root of both sides of the equation. If I do that, remember that you need to consider both the positive and negative square roots of both sides. But in the original function, x was restricted to being greater than or equal to 0. In the inverse, all the x's in the original function become y's, which means for the inverse function, y has to be greater than or equal to 0. That allows us to drop the negative part of our plus or minus and conclude that the inverse of f is the positive square root of 4 minus x. Now I want to graph this function and the original with the restriction to verify this result. So back to our graphing calculator. In y equals, I'm going to clear the first two lines but keep the y equal x so it can divide the quadrants 1 and 3 and show me my reflections. The first function has a restriction, so I'm going to put it in this way. Parentheses negative x squared plus 4, close the parentheses. If you use a division symbol, another set of parentheses, put in x, select test off the keypad, and I want to choose option 4, and then put in 0. In this way, the calculator will graph exactly negative x squared plus 4 only for x greater than or equal to 0. The other function is the square root, so I'll select the square root key. Remember that there's already a parentheses there. Put in 4 minus x and close parentheses. I think this time we can zoom standard and get a pretty good graph. There's the function. There's the inverse and the line y equal x. Notice that y equal x splits the two functions in half. Where they intersect is on the line y equal x. Let me point out one other thing. The original function contained the point 0, 4, and its inverse the point 4, 0. They have their ordered pairs in reverse order. In this lesson, we've looked at a function and its inverse. We defined one-to-one function and found a way to find a rule for the inverse of a function. Be sure to practice by doing many problems from the exercise set in your textbook.